In section 4.3, we proved triangles congruent by looking at all three sides. If we had three pairs of congruent sides, the triangles were congruent to each other. Well, it turns out that there's more than one way to prove triangles congruent to each other. If we have a pair of congruent sides and another pair of congruent sides, and the angle between those two sides, in this case angle B and angle E, congruent to each other, then that's enough to prove that the triangles are congruent by side, angle, side. So if we have a pair of congruent sides, if AB is congruent to DE, and the angle that's between the two congruent sides, in this case angle B congruent to angle E, that's called the included angle because it's included between the two congruent sides, and BC congruent to EF. That's enough to lock in congruent triangles. If I have this information, these two triangles are forced to be congruent to each other. So now we have two ways to prove triangles congruent to each other: side, 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 or side, angle, side. Let's take a look at some examples to figure out which postulate we would use. In this first example, we have a pair of congruent sides and a second pair of congruent sides, and then this third side is shared between the two triangles, so it's congruent to itself by the reflexive property, giving me a third pair of congruent sides. So I have 1, 2, 3 pairs of congruent sides. So these triangles are congruent by side, side, side. In the second example, we have a pair of congruent sides. We have a pair of congruent angles. And we have a shared side, so by the reflexive property, it's congruent to itself. So these two triangles are congruent by side, angle, side. Remember, when we talk about a pair of an S, that's a pair of congruent sides, a pair of congruent angles, and a pair of congruent sides. My third example, I have a pair of congruent sides and a second pair of congruent sides. And because of the way that these triangles are drawn, we have a pair of congruent angles because they're vertical. Those two angles being vertical makes them congruent, so these triangles are congruent by side, angle, side. Let's take a look at a proof that proves triangles congruent to each other. We need to prove that triangle A, B, C is congruent to triangle D, C, B. And we're given that AB is congruent to DC. So we know that we have a pair of congruent sides automatically. We're also given that angle ABC, this angle right here, is a right angle, and angle DCB, this angle right here, is a right angle. Well, I can prove that right angles are congruent to each other. It's going to take a little bit of work, but I can do that. So if these two angles are right angles, these two angles will be congruent to each other. And finally, if you notice, this third side, this BC and CB, is shared between these two triangles. So it's congruent to itself. So these two triangles will be congruent by side, angle, side. So that's my roadmap. I want to use side, angle, side to prove these triangles congruent. I'm going to follow this roadmap. I'm going to first prove that I have a pair of congruent sides. Well, that turns out to be my first given. My first given in this proof gives me a pair of congruent sides. So I've taken care of a pair of congruent sides. Now let's go to a pair of congruent angles. Well, to do that, I need to prove that these two angles are congruent to each other. So I'm going to start with my given, that ABC is a right angle. And I know that if I have a right angle, by definition, when I measure it, its measure equals 90 degrees. That's the definition of a right angle. Now this is important because it gives me an equal sign. I know how big angle ABC is. It's 90 degrees. I'm going to go on to my final given, that DCB is a right angle. Well, I know that if I have a right angle, if I measure it, its measure is 90 degrees. So the measure of angle DCB equals 90 degrees. That's the definition of a right angle. Now it doesn't seem like I've done much, but I've introduced an equal sign into my proof. And both of these angles both equal 90 degrees. So I can take statement 5, and any time that I see 90 degrees, replace it with the measure of angle DCB. So I can take statement 5 and plug it into statement 3 to create statement 6. The measure of angle ABC is going to equal the measure of angle DCB. I can call that substitution. I can replace my 90 degrees with the measure of angle DCB, or the transitive property. They both equal 90 degrees, so they equal each other. Now I don't quite have my pair of congruent angles yet. I've said that their measures are equal, but I know that if two angles have the equal measures, by definition of congruence, they are congruent to each other. So once I have their measures equal, I can say that the two angles are congruent by the definition of congruence. Now that's enough to prove that I have a pair of congruent angles. So I followed my roadmap, side, angle. Now I need to go to that pair of congruent sides, my final pair of congruent sides. And if you remember, that was this shared side between the two triangles. So BC will be congruent to BC. Now whether I call this side BC or CB, they both mean the same thing. The reason that BC equals BC, the reflexive property. That gives me my final side. So I followed my roadmap, side, angle, side. That's enough to conclude that my triangles are congruent to each other. My reason, side, angle, side.